Can you see the presentation?
No,
Yep.
now this, no, okay, now we see.
Okay, yeah. Good afternoon. My name is Artem Hovrat, and now I want to present the results of study conducted by the Kharkiv National University of Radio Electronics and Lodz University of Technology, implementation specifics of log-free containers for high-loaded multi-threaded application. Globalization and digitalization are significantly rising the volume of information processed by socially focused systems, such as social networks, military platforms, and fintech solutions. Recent crises like COVID-19 pandemic have exposed weaknesses in even the most silent software systems under high demand conditions. In this scenario, the reliability and efficiency of algorithm are vital for key institutions, like banks and governments. That's why modern systems often struggle to handle spikes in data and traffic, leading to performance bottlenecks and high risk of failures. To resolve these problems should be explored innovative strategies and methodologies to enhance data flow and improve system resilience. The specified motivation becomes the basis for the use of various approaches to the parallelization of information processing. The classical approach to solving such problems involves the use of the so-called log-based method, which is focused on orchestrating certain data streams and involves blocking parts of the code. So for now, the development process shifts its focus from planning efficient data organization to managing the execution sequence of various program components in a multi-threaded environment. Consequently, the primary goal of optimization becomes accelerating the data transformation processes rather than improving data organization quality. In this paper, we have chosen to explore an alternative approach that employs no-log techniques. This approach, aside from inherently avoiding the drawbacks mentioned earlier, also shows potential for improved speed performance. So the purpose of the work is enhance data flow and system resilience by examining alternative to traditional locking mechanism. You can familiarize yourself with the key tasks on the slide and also with the main sources of information to determine the specific issue of the current domain. To understand the essence of log-based and log-free approaches, first of all should be clarified target domains to this type of software systems. Social networks, high user engagement leads to massive data traffic. Financial systems, transactions require real-time processing and high reliability. Military applications, data integrity and speed are crucial in critical operations. Cloud services, scaling to accommodate fluctuating demands is essential. Trafficking systems, real-time data processing is needed to manage and optimize traffic flow. When aggregating these and other domains that require high-load systems, two main areas emerge where performance significantly impacts both software solution and society as a whole. Financial and reputational consequences. Service outage can lead to significant financial losses or penalties due to disrupted transactions, and human and public safety risks. In critical systems such as military and healthcare applications, performance failure can lead to human casualties. So after examining the core motivations for employing both log-based and log-free approach, uh, we are now positioned to conduct a comparative analysis of these two sides of one medal. For log-based approach, focus on exclusive ownership of code section using logs to prevent concurrent access. Uh, the techniques employed can vary with internal storage mechanism commonly seen in container implementation, and for instance, incrementing a global counter necessitates the use of mutex to ensure that only one thread can modify the counter at any given time. For log-free approach, log-free leverage hardware intrinsic atomic operation to manipulate memory without the need for locking. They employ compare and swap or cache loops for atomic updates. Also, they are susceptible to issues such as ABA problem. And critical operations are designed to guarantee that no thread can observe intermediate states during execution. Prior to exploring the specific characteristics of the practical implementation of log-free methodologies, it's crucial to consider one important challenge. The principal issue affecting data flow in high-loaded system is back pressure. This phenomenon arises when consumers cannot adequately process the influx of information before additional data is generated by the producer. Current software solution tackles this problem using three key techniques for request management. First one, controlling the producer. This technique involves intentionally showing the flow, the flow of information from the source. It's effective in scenarios where data are organized from multiple user interface elements. However, it's impractical for systems reliant on automated data source, such as delivery of quotes from electronic exchange during a core trading session. The second one, dropping extra data. This method entails discarding certain blocks of incoming information that cannot be processed in real time. It's particularly useful in applications like streaming platforms. Conversely, this approach is not appropriate for critical infrastructure systems, where losing even one or two consecutive messages can have serious repercussions. And the last one, buffer and receive data. This strategy involves creating an additional buffer to absorb sudden increases in load, thus mitigating their impact on the systems while maintaining overall throughput. This solution is ideal for critical systems where managing the volume of incoming data is impractical and where preserving data integrity consistency is paramount. That's why the future discussion will focus on the effectiveness of this approach and ensuring data reliability and continuity of high-stakes settings. So the diagram on the left side of the slide illustrates the fundamental approach to addressing the challenges of buffer and receive data. Upon establishing the data source, a thread labeled as the producer interface, thread in the diagram is initiated to facilitate data retrieval. This thread is tasked with collecting data and aggregating it into a secondary structure known as a shared container. Subsequently, data processing is distributed among multiple threads, which are designed to access the information from the shared container and execute the necessary processing tasks. A potential enhancement to the previously described systems involves the integration of an external memory block at the intermediate buffer level. This modification would enable operation to be conducted not directly on the data within the shared container, but rather on pointers referring this modification rather pointers referring that memory. The strategy could mitigate the risk of blocking the container during data access, thereby further optimizing the overall process. The schematic representation of this modification is depicted on the right side of the slide. So we can move on to practical implementation of this approach by pseudocode, which you can see on the left side of the slide. It's a log-free queue. First of all, the log-free queue class maintains head and tail pointers for the queue. New nodes are added by attempting to update the tail pointer user a compare and swap operation, case, ensuring thread safety without logs, and nodes are removed similarly. Updating the head pointer with case, allowing multiple threads to operate concurrently without blocking. The main challenges of this approach is following. ABA problem, a situation where location value is read, modified, and changed back, leading to incorrect assumption about its states. The second one, complexity in implementation. Designing and maintaining log-free data structures is often more complex than traditional locking mechanism, requiring a deep understanding of concurrency and atomic operation. The third one, performance trade-offs. Under log contention, log-free algorithm may not provide significant performance improvements and can even perform worse than their log-based counterparts. And the last one, debugging difficulties. Concurrency introduces non-deterministic behavior, making it challenging to reproduce and debug issues with log-free systems, often leading to subtle bugs that are hard to identify. To alleviate some of the identified challenges, the following techniques may be utilized. Thread local storage, log-free data structures, optimized input-output patterns, memory allocation strategies, cache alignment, hot memory, new memory placement, and false sharing mitigation. You can see the short description of these approaches on the slide. Let's move on to determine the experimental environment. After the expert evaluation among 50 specialists from the Ukraine, Poland, Austria, Portugal, and the United States, the following indicators were selected as key efficiency criteria. Performance metric is measured in seconds and has an importance factor of 12. Load balancing, measured as a root mean square deviation from uniform load distribution among consumers. This metric has an importance factor of 2. And stability. This metric is evaluated by experts on an inverse scale from 0 to 10, where 0 represents complete stability of the system and 10 indicates critical instability. It holds an importance factor of 6. So the following formula can be approached for the effectiveness evaluation. You can see this on the screen. Regarding the dataset, the first dataset contains information on stock market transactions, specifically the status of the order book. For a single ticker, the daily message volume exceeds 1 million. To increase the load, 23 tickers from the Dow Jones Index listed on New York Stock Exchange were selected. The second dataset comprises air quality sensor data. A similar dataset encompassing information from Italian cities dating back to the early 20s was located on the Kaggle platform. On the screen, there is a chart presenting the normalized evaluation results of the two models. Consequently, both approaches produce similar outcomes. It also noteworthy that log-based solutions present certain limitations, such as potential disruption of load balance among consumers, especially when prioritizing is a factor. In extreme cases, this imbalance may reach up to 25%, which can further undermine the efficiency of such systems. Nonetheless, considering the recommendation from the expert group and the potential for enhancing the approach with log-free techniques, it can be argued that this container implementation is well suited for socially oriented systems that demands swift task execution. So the study aimed to formulate a set of basic common specifics on the implementation of no-log containers and compare it with log-based containers. The following outcomes were achieved. The characteristics of log and no-log implementation utilizing stack and queues were examined, and bespoke versions of this solution were developed. And a log and no-log containers were implemented based on the queue and stack, and multi-criteria selection problem was formulated to test the proposed log-free approach. The results highlight that also log-free approaches can deliver greater efficiency as their configuration is significantly influenced by data consistency, particularly in terms of size and the execution time necessary for subsequent processing. This dependency may necessitate considerable time investment during the development process. You can see the list of used sources on the slide. Thank you for your attention.
Thank you. Who have questions, please?
I have a questions. Can I ask?
Yes, you have.
Yep.
Good day, Artyom. I like to see you. I have questions. You said about many approaches and algorithms. In your experiment, you use all of this algorithm or some?
If you speak about queue and stack or data structures and algorithms to...
Yes, about this experiment.
Yes, we implement all these algorithms, data structures, and test it and describe it into our research papers.
Algorithm. Okay.
Yep.
Mm-hmm. Thank you.
Okay, thank you. Any questions? Thank you very much, Artyom. We have maybe we have exhausted our section program, I think. Thank you all for participating, and please note that you will need to revise your submitted papers according to reviewers' comments and upload your papers as soon as possible. You understand me?
Yes. Thanks.
Yeah, okay. Well, no, thank you very much. Our section is over. Thank you. Have a good day.
Have a good day. Thank you.
Bye.
Yeah, have a good day. Bye.
Bye-bye.